Good morning or good afternoon. Here are some updates from the Safety-Related ONNX Working Group, or ONNX. I'm Eric Jan from the Technological Research Institute Saint-Exupéry. This presentation was created with the working group co-lead Jean Souiris from Airbus. We are both based in Toulouse, France. In this presentation, I will briefly remind you of the objectives of the working group, give you some information about how the group is organized, and provide a quick overview of some results. And I will finish with some information about the upcoming activities. The ONNX working group has the general objective of providing the means, and specifically the language, to describe an ML model intended to be integrated into a system whose failure has a significant impact in terms of safety, financial consequences, etc. Industrially, this usually means demonstrating compliance with the regulatory framework defined by standards. And in the aerospace sector, for example, this means demonstrating compliance with the SAE ARP 6983 standard, which specifically addresses systems with AI components. In this standard, the ML model is referred to as MLMD for Machine Learning Model Description, and it plays a central role in the development cycle because it bridges the design and the implementation phases, as you can see in red on the picture. In this context, the goal of ONNX is to extend the ONNX standard by clarifying the semantics of a graph and its operators, restricting the currently available elements and their semantics to simplify demonstrating compliance with the standards, and finally offering a reference implementation that can serve as a test oracle for the model implementers. Since the start of the project in September 2024, we have held 15 working group meetings. After a kickoff meeting with around 50 participants, whose affiliations are listed here, attendance at the meetings has ranged from 6 to 15 participants. Participants are fairly evenly split between industry and academia. In addition to these working group meetings, we have organized a small workshop on the use of formal methods and several meetings with representatives from the WG114 working group, which is currently developing the ARP 6983 standard that I mentioned earlier. We also presented our work on 2 occasions, including a fairly general conference held in Paris on the embarkability of AI. We have planned the deliverables shown on these slides. Those marked with a click logo are available in the group's repository on GitHub in varying states of completeness. The timelines we proposed at the kickoff were very optimistic, and I must admit we did not stick to them. Deliverable D1A concerns the definition of the ONNX profile scope, that is, the subset of the ONNX operators that industrial participants deem necessary to address in an initial phase. Deliverable D1C collects the needs of industry stakeholders, especially from a certification perspective. Deliverable D2A translates these needs into requirements. And the series of deliverables D3B to D3E constitute the core of the work to be done. Currently, most efforts have been focused on specifying operators, and I will present an example in the upcoming slides. Deliverables D4A and D4B aims to verify and validate the earlier results, and this work has not yet begun. Finally, I want to mention 2 additional deliverables related to model verification, particularly checking compliance with the rules and restrictions we are identifying as part of the operator and graph specification work. We'll see an example of this later. Another result, which was not originally planned, is the creation of a reference implementation, and I will speak about that shortly as well. To give you a concrete overview of the project's results, let's have a very quick look to a sample of informal and formal specification. For each operator, we first provide an informal description. This is part of the documentation and aims to clearly explain the behavior of each operator. Here is an example of documentation for the conv operator, which performs a convolution. This documentation provides a mathematical description of the operator, defines usage constraints, for instance, the relationship that must exist between the shapes of the input and output tensors, and specifies some usage restrictions with respect to standard ONNX. Those restrictions are introduced either to simplify demonstration activities or to meet some specific industrial requirements, for instance, the need to give an explicit value to attributes rather than relying on default values. This informal specification is complemented by a formal specification written in YML. YML is the input language of the Y3 formal specification and proof environment. An example of a formal specification in YML is given here for the concat operator. This is only part of it. This formal specification clearly and unambiguously describes the semantics of the operator. Our objective is to refine this specification to the point of allowing automatic generation of an executable specification that can serve as a test oracle. The first executable specification is written in Camel, but after our last refinement phase, an executable specification written in C is obtained, again using automatic generation. The key point here is that full conformity between the various levels of specification and ultimately the implementation is rigorously ensured. This diagram summarizes the links between the project's three main outputs. The informal specification is the entry point of the process. The formal specification describes the same operator in an unambiguous and complete way using a formal language and is traceable to the informal specification. The formal specification may first express some expected relations between the inputs and the outputs. This specification may be transformed into a procedural one that describes how to obtain the outputs from the inputs. This procedural specification may be further refined in order to become executable. The first executable specification will be in OCaml. The last executable specification will be in C and will become our reference implementation. After this brief overview of our objectives and our first results, what is coming next? First, we are far from having completely specified, even informally, all the operators, and this work will continue this year. In parallel, we are also doing the same work for the graph, trying to answer the questions, what is a graph, how is it executed, etc., both informally and formally. Once the formal specification is done, we should normally be able to provide the C reference implementation, first for the operators and then for the graph. We will also complete our preliminary work on the question of verifying numerical approximation. Finally, we also have to start addressing the question of how our work will be integrated or not in the ONNX ecosystem. Thanks a lot for your attention. If you have any question or need clarification, don't hesitate to contact me or Jean. We will be very happy to give you more details on what has been presented today. Bye-bye.